All right, let's talk some properties of exponents. So I'm going to go through some very basic problems where we're going to simplify using properties of exponents. Now, the one thing to remember is because there are shortcuts out there, this, that, and the other, a lot of times it's really hard to keep those straight. There's one thing that you need to remember that kind of keeps it all clear. So the easiest thing to tackle properties of exponents is when in doubt. So anytime you're stuck and you're not sure what else you need to do, when in doubt, write it out. And I'm going to show you kind of what that means through these various examples. Yes, there are other shortcuts that you may find, this, that, and the other. For people that are starting with properties of exponents, I try and shy away from those because I want to keep it simple so they get a basic understanding, and then maybe down the line they get those shortcuts. So my first problem, we need to simplify x to the 8th times x squared. So we're dealing with properties of exponents. The big deal is up there, that is an exponent in the superscript there. So that is what we're trying to do. So I have two bases of x here. When in doubt, write it out. What I mean by that is when you have x to the 8th power, what that means is you really have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7, 8. 8 x's represent this x to the 8th power. So when in doubt, write it out, all 8 of them there. So it's really just, do you know how to count is how you're going to do these problems. So I have my x to the 8th, there it is. And I have to multiply that by x squared. Well, x squared would be just x times x. So here's what I mean by writing it all out. Now, how is that useful for us is we can condense this back down by counting up all the x's there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So that is x to the 10th power. So that's what I mean by writing it out. So let's go on a little bit more complicated problem. So that was multiplication. When we have division here, like y to the 3rd divided by y to the 5th, not quite sure where to go with this. So there is a division sign there, so let's put our division sign here. I'm going to write out the top and bottom. So y to the 3rd is y times y times y. And on bottom, we need y to the 5th, so 5 of them. 1, 2, 3, 4, 5. Now what's going to happen here to condense these down is I would condense back and I'll just go right back here. We could simplify this a little bit. And what I mean by that is, notice how we have the same thing on top and bottom. Just like in basic math, like if you did 4 divided by 4, you get 1. Notice the 4's are gone. Same thing is going to happen here. So I have a y up here divided by a y in the denominator, the bottom. That's actually 1. So I cross those out. Words you may hear as they cancel out. But really they're just dividing to 1. Take a y for a y, y for a y, and notice I just took 1 for 1. 1y for 1y, 1y for 1y, 1y for 1y. I can't cross out these two because there's no y's up top to cancel out with it. So when I write my answer here, I need to just, still have my division sign. And then let's just write down what's on top and what's on bottom. Up top, in the numerator, I crossed everything out. Everything's gone. So there's nothing there, but what we're going to write is we're going to write 1. Because remember, everything divided to 1. So whenever it looks like there's nothing there, it's really just a 1. On bottom, we just have y times y, which is y squared. Alright, so moving on to the next problem, I have inside parentheses 3x squared. Outside the parentheses, I have a power of 3. Now this is one that I do kind of like to use a rule to get through it because especially in the more complex problems that we might run into, this rule does help. We have here an x squared on the inside. Now one thing that a lot of students get confused about is they think this square also applies to the 3. That is not true. This is really 3 to the 1st power, and that's an x squared. They each have their own exponent. This 2 doesn't apply to both of them. So it's 3 to the 1st x squared. So we have exponents inside the parentheses as well as an exponent on the outside. So with properties of exponents, we're really condensing down and simplifying. So we need to get these exponents together. The way we're going to do that is if you go through parentheses there, we're going to multiply the exponents. Meaning I'm going to take this 3 and multiply it by that exponent of 1. So I still have that base of 3 there. And then the exponents, 3 times 1 is 3. So I have 3 to the third power. Now you could figure out what 3 to the third power and simplify that and say it's 27. I'm going to leave it like this just so we can kind of see how the properties work. We also have to take that 3 and distribute it to the other exponent in there. So this 3 times the 2. Well, 3 times 2 is 6. So we keep the base of x. Now we have exponent of 6. Another property we have, now I talked about this much more in length in class, but I'm going to keep it simple for this video to save some time, is anytime you have a base to the exponent of 0, so anything to the 0 power is always going to be 1. Now I did expand this further and show you, well, why is this the case, and it does have to, and I can show you with an example of that, so I could show you that some other time. And finally, we have, by the way, that's always going to happen, any type of base. You can have x, y, z, 1,000, 1,000,000, whatever down there. Anything to the 0 power is always 1. The final thing I want to deal with in this video is negative exponents. So these are very, very tricky. What we're going to do is we're going to do the reciprocal. So the thing you need to be careful of is most students say just flip everything, because that's what the reciprocal is. That is not true. We are not going to flip everything. The only pieces that move are the bases that have a negative exponent attached to that. What I mean is this y is raised to the negative third power. This x is raised to the negative second power. So those both have negative exponents. But some people will think, well, this 3 also has a negative exponent as well. That is not true. This is really written as a 3, x to the negative 2, y to the negative 3. That 3 really has an exponent of 1. It's just not something we write just like we had earlier. So it has an exponent of 1. So what you want to do with these problems is there's going to be some shifting. If you have a base with a negative exponent and it's in the top, it's going to move to the bottom and the exponent becomes positive. If it's in the denominator, the bottom, and you have a negative exponent, you're going to move it to the top and make it positive. So I originally started with a division line here, so I'm going to keep that. And let's go through piece by piece and see, well, what's moving, what's staying. So I have 3 to the first power. This 3 does not have a negative exponent with it, so we're just going to leave that 3 up top. Then I have this x to the negative 2. So it was on top. Because it's a negative exponent attached to it, it's going to come to the bottom and change to positive. So I'm going to have an x instead of negative 2. Let's make it positive 2. And then on bottom I have y to the negative 3. That is a negative exponent. It was on bottom, but because of the negative exponent, we're going to take the reciprocal, which sends it to the top. So I now have a y to the positive 3. The other thing you want to check for, especially in more complex problems, is you want to expand this out and see, x's, y's. That all, simplifies out. But since I just have an x here, a y there, a 3, nothing else we can do. So there is your answer there. And that was basic, very basic properties of exponents.